All right, yeah, welcome back again. Now, we last time we look at pair data, so that is called dependent uh, pair data. So it's dependent because if you remember, the specimen we use repeatedly are the same specimen, the same people, the same experiments, same subject rather, that we use repeatedly. That is before and after. So sometimes people do not understand the difference between pair and unpaired. All right, so they are confused sometimes, but it's very easy to understand if you follow the explanation I gave last time regarding the pair test. It's very straightforward. Okay, you have the same subject. You want to experiment repeatedly the same thing in within some time frame or time differences. All right, so that is what it means. So you have tested them before, you let them come back. It's like you have a patient. You tested the patient. Say, okay, patient, you come back tomorrow. You want to examine the patient again and see the difference if what you administer to the patient works on the patient. So that is just as a separate experiment called paired test. That's what you have done. But now you have only one patient. So if you have like 10, okay, the same thing can be done. But now based on the same administration of maybe drugs or prescriptions. So now let's look at the unpaired test now. So we have a weight of a subject now, male and female, right? Woman and man. We have the weight measured. So this is called independent test now. It's called the independent sample because they are not dependent on each other. Man is not the same with woman. They are different. Okay. So this is very common data we always see all the time. It's very common data, but sometimes people don't know which data to use for which experiment or which test. All right, so they are confused, and you must be able to use appropriate test for that data so that they can have a proper experiment. All right, so the essence of this kind of a test is to compare the mean of two independent samples or groups. That's the purpose. Okay. Last time I was giving a lot of experiments. I mean, a sample for this particular one when I dealt with it in R. I give another example apart from this that is there a difference between people who have a college degree and people who don't have in terms of their F, maybe BP, understand? Maybe or two production lines produce screws with the same height today. All right. So you can ask a question. Maybe I want to say, okay, do smokers have high risk of heart attack than not smokers? See that? What you're trying to do that you are trying to ask this question because you want there's always in one numerical variable and one categorical variable, which is in two groups. They are in two, maybe male, female, smoker, non-smoker, uh, uh, BP, no BP, okay, and so on. Okay, so this just like that. All right, so it's as simple as that. College degree, no college degree. You see that? So that is just like that. So it's very simple and easy to understand. Or maybe you can say, is there any difference between the salary of a men and women in a JJ company? All right. So that means you have male and female now, and there's the variable here is called salary. Where you have a categorical variable is called uh, uh, gender. So it's as simple as that. So now in past, you can just if you have to first test first, if they meet a parametric test first, you can copy this one test to pass first and check. Let's do that first and check quickly. So just paste that one here to check first. Let's just paste. So we want to look at Shapiro first. Oh, sorry, something's not right here. Supposed to be here, not there. So what do I do now? Okay, let me just paste again afresh. All right, able to quickly paste here. Okay, yes, okay now. All right, so looking at the Shapiro here, I see that it's not significant, which means that it passed Shapiro test. Shapiro test was passed even for Anderson and Monte Carlo. So which means you can go ahead with what a parametric test of a unpaired to sample test unpaired. Okay, so it is called parametric test. Okay, independent unpaired sample test. That's what it's called. So can go ahead now. So how do you do that now? Let me just clean up this so that we can bring the data here. I told you before that if you want to do in a pass, you have to break the data into two. You have gender here, so you don't do it this way. So just copy, just take a woman here, man here, or male and female here. Each of the group, you have to group them out. Then put your data under them. Because you just copy this and put under here. Okay, copy this one and put under here. That's all. Then you have the two sample already. So copy it and copy it together. Then come to pass. Paste it here. All right. So we have the two sample now. So in pass, we don't have unpair actually in pass. Okay, take note of that. There's nothing like unpair sample like that in pass, but the pass has a way of helping you how to get to do it very easily. So what you need to just do is that you need to apply some techniques, manual techniques to do it. When I mean manual, I'm not saying completely manual. All right. What you just first do, just first to know some variables, some parameters first that you have to supply for you to test. You need to know the mean, the variance. Of course, you know the total number of sample for each group. You have 10 only, just 10 for each group. Okay, that one is clear. If you have 100, 20,000, it's okay. Just supply it. So you need three parameters. You need the mean, you need the variance, and you need the total number of the sample. So we select the two together now. This one and this. Okay. All right, we calculate first. We find summary. Click on summary statistics. Okay, summary. We have what is mean? 68 for man, 68.97 for woman, 52.11. Okay, so what are variance? 78.13 and 216.22 variance. Then total is what 10. That's what you need. So you have to write it down. Okay, then supply it later. So let's perform the experiment now. So if you come here, click on the two test here, click on F and test parameter. So this is how you do it. Okay, F and test parameter, click here. So now this is sample 1, this is sample 2. Okay, so and supply the mean here. What don't forget the mean we have the other time. We saw the mean there just now. What do you have as mean? We have 68.97, 68.97. Take note of that. For the sample 1, which is man. Okay, we also have for the variance, what do we have? We have 78.1, 78.1. Then total is 10. Okay, for sample 2, which is a woman, we have 52.11, 52.11. All right, and we have variance is 216.2. Then total is 10. The number of sample is 10. So what do? Just compute. That's all. Click on compute. So what do you have? Now this one will give you F automatically 2.7, which is good enough. Then we have T. T is equal to what? 3.1079. Your mean value is 0.666, 0.006, which is significant. That's all you need. That's all. You are done. This is unpaired. So this is how you can handle unpaired in past. All right. So if you look at let me show you the result for R for this. Don't forget we have T 3.1079 and P 0.666, 0.00, okay, 0.0000206. Okay, take note of that. Okay, so let's go to R. I've done this in R also. So you can see that what you have in R, we have 3.107. Okay, we have B value to 0.006. The result is the same. Okay, and your mean, what you get your mean is 68.97, 52 point the other time. So which means significant. That's what you get here. So look at the same thing here. Okay, 3.107, 1075, 1079. Nothing much difference. Okay, you can approximate that. Okay, 0.0060 and same thing here. It's 0.0060 here. You can see 0.0060. So what do you want? You are done, and your mean is 68.797, and same thing here. So which means you're good to go. So which means pass is not bad. So it's very simple. Just click and compute. All right. So that is that for today. I will see you in the next class when we're doing something that's more interesting. Thank you so much. If you have not joined, you can just click to join and subscribe. Thank you. See you later.